Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zikri Askia. I'm from Politeknik LP3I Medan, Indonesia. Today I will present our product with tile implementation of solar power plant with Internet of Things on Politeknik LP3I Medan laboratory. Our team is there is Rizky Syahputra Harahap as our captain, and the other Rizky Syahraini, myself Muhammad Zikri Askia, and our lecturer is Rizaldi Khoir. Okay, next. In this era, there's a lot of electronic products that we use to help us to doing something, and those electronic devices is using an electricity to run the devices, and the electricity came from electronic company, and sometimes the electric companies always shut down the electricity, so that will make us disturbing that when we use our electronic devices. And the solution is we use alternative energy, and usually the alternative energy always come from solar panel or wind turbine or generator. Okay, next, the introduction. Electronic equipment has become a part of life in helping many people to carry out activities, but electronic equipment requires electrical energy from the state electric company. It named PLN in Indonesia. In running such electronic equipment, and it is not uncommon for power outage to occur when we are carrying out activities. Based on the above problems, the authors made a tool with tile implementation of solar power plant with Internet of Things on Politeknik LP3I Medan laboratory, which will be used in anticipation of power outage in the IOT laboratory. Okay, next. All right, this product will run when there is no electricity or all electricity is down, and this product is using solar charge controller. This solar charge control is an electronic device that function to charge the battery or accumulator of a solar panel or other with electric current, direct current, DC. More with the aim that the electric current flowing into the battery or accumulator become more stable and able to regulate the flow of incoming to the battery. So these devices will save the battery of overcharging. And then this product is using 12 volt and 3 to 10 amps battery. And the solar panel is 12 volt to 24 volt. And the solar panel is 12 to 20 volt and 0 to 5 to and this product using a solar panel with 12 volt to 20 volt, and the current is 0.5 to 10 amps maximum. Solar panels are the main equipment for solar power generation systems that function to convert sunlight energy into electricity directly. And there's a button to use for emergency stop when this product runnings, but we don't want to use this product. You can use this button to stop the product runs, and then we use Wi-Fi connection to the product, so that's why we can connect. So that's why we can communication from our smartphone to the product. And also there's a time this product is using time module for control that this product will not use on night day or on Sunday or Saturday. So it just like this product will not use on holiday. Okay, next, this is the circuit diagrams. This diagram is using 6 relays and 1 button. And also this is smartphone battery that using for detection. This is the smartphone charging. This is for detection of electricity when the electricity is down or die. And also the inverter. The inverter will use to generate from this 12-volt battery to 220 volt to 220 volt. Also this is a inverter that will use to convert from this battery from 12 volt to 220 volt, and the current will convert from direct current to the alternating current. Why? Because some electronic devices is using 220 volt and using alternating current. And also this is the solar charge controller and the solar panel. Okay, next, this is the flowchart. There are 2 flowcharts. First flowchart is the solar panel, where the solar panel will charge. This is about the charging of solar panel. So from start input of the solar panel, and it will goes to solar charge controller and then goes to the battery. When the battery full, it will cut off the current of solar panel. So that's why when the battery full, the solar panel will stop to charging the battery. And then the second flowchart is the device flowchart, or we can say as a driver of that circuit. So the first is the input of the input when the blackout, we have blackout, and this is a clock from 21:30 and 7:00, and also this is Sunday or Monday, and the button when you press it. So the first is from this boolean is when the button is pressed and the value is yes, these devices will send to our smartphone as the text is status lab is closed. That's when you are press the button. So it will goes like this, it will running when you press the button and so on. But you unpress the button, it will read, is this blackout or no? If the value no, it will send the text to your smartphone with status on. It means the electric is available. There is no blackout. But when blackout, it will goes to this. It will read, it is 21:30 or half 22 in the night day. I mean at 9:30, or this is above of 21:30, and this is under 7 in the morning. When the devices is run in the morning, if this thing is blackout, it will goes to this boolean. It will read that the time is, it is above 21:30 o'clock or under 7 o'clock in the morning. If the value is yes, it will send to the smartphone. It will send to your smartphone with text, status lab is closed. If the value no, it will goes to this boolean. It will read that it is Sunday or Saturday. If the value yes, it will send to your smartphone that status lab is closed. It means the laboratory in campus of, but the value is no, it will reach. Is this Sunday or Monday? Is this Sunday or Saturday? If the value yes, it will also send to your smartphone that status lab is closed. It means the laboratory of Politeknik LP3I Medan is closed. Politeknik LP3I Medan is closed or holiday. And also if the value no, when you are in campus and the blackout is happen, it will turn on the generator to back up our devices, and also it will send to your smartphone that status is using solar panel, and so on. Okay, this is about the flowchart. Next, we go to research, resolution, and discussion. Okay, from this picture, we can see that the component. There are power inverter with 200 watts and solid charge controller, microcontroller, node MCU, power supply, and this outlet, and also relay, module relay, battery, and boost converter. Okay, next. Okay, for the testing, when you plug the power to this outlet, it will send to your smartphone that status is on. And if you remove the plug from this outlet, it will send that status using solar panel. And as you can see, this light is on. It's actually on, and when you unplug, it's also on because the generator is runs from this battery. This is the battery with 12-volt battery from 18650 battery. Okay, this is a video atau bukan Pak? Bukan video ya? Oh bukan ya. Okay, next, when you press the button, it will send to your smartphone that status lab is closed, and also lamp doesn't run on automatically. Okay, the power plug, when you remove, it must be when you unplug, when you remove the power. Lupa saya. Okay. Okay, next, when you press this button, it will send to your smartphone that lab is closed and lamp doesn't turn on automatically. So when you remove the plug, it's actually a simulator. It is the simulator for testing that this device, this product runs when the blackout. When we are in blackout, so because you press the button, the status will it will send the text to your smartphone that status lab is closed. It means lab is closed, or when you are in that time, when you are in 21:30 in the night o'clock and on 7 o'clock in the morning. Okay, this is the installation. This is the installation of the product in the IOT laboratory of Politeknik LP3I Medan. It hanging on the wall. Okay, and the solar panel is out of the lab. Okay, the conclusion is, based on the discussion that has been described, that author can draw conclusion from the making of the IoT-based solar power plant application at the IoT laboratory of the LP3I Medan Polytechnic, namely that at the time of a power outage, the user can turn on the tools manually or wireless by using the online remote XY application to use energy, alternative electricity, so that it can be used sparingly. But if the electricity is not in blackout, then this power plant will not be turned on manually or online. The author also gets knowledge and is able to how to produce electricity that is environmentally friendly and can apply IoT technology to solar power plants. Thank you.